We're going to start doing now the fourth page, which has some graphs on it and stuff. We're going to start with number 11, which is pretty straightforward. This is similar to those other ones we did with the remainder theorem. It says, for what value of m would this guy be a factor? Well, in order for something to be a factor, you start off by looking at this and you say, what would make this 0? -2 would. So if it's a factor, it means if you plug in -2 for x, every time you see an x, it has to equal 0. So now we go ahead and do this. So -2 cubed is -8 plus -2 squared is 4. 4 times 8 is 32 minus 2m plus 18. Okay, put these two together. I get 24 minus 2m. And finally, this and this make 42. Going to move the 2m over to the other side. Divide by 2. M is 21, and that's all there is to it. So that's our first guy. Now, let's move into our graphs. Anytime I go to graph this thing, I always factor it first. So this is going to factor into x plus 2, x minus 1, all over x plus 1. And now I'm going to go and see what I'm asking for here. X-intercepts, that's the same thing as saying the zeros. I like to do that first. That means what makes the numerator 0. And one of those is going to be the point -2. So that's one of our x-intercepts. And this would make it 1. So that's 1, 0. So we have 2 x-intercepts. Y-intercept means plug 0 in for x. So that makes 2, -1 over 1. So that means when I plugged in 0, I got -2 as an answer. I always like to do those first. Now, wholes. Does anything cancel off here? No. So it means there's going to be none as far as wholes go. Vertical asymptote means what makes the denominator 0? That'll be -1. So you're going to write x equals -1. Now, finally, horizontal asymptotes. That's when we bring in our limits. So I'm going to do the limit as x approaches positive infinity. The limit as x approaches negative infinity. What's the most powerful thing in the numerator? X squared. And the most powerful thing in the denominator is x, which reduces to be x. Okay, same deal here. Now notice we did not get a number. That means there are no horizontal asymptotes. However, we've got x. This means y equals x. Whatever is left over here is a diagonal asymptote. That means the line y equals x is something that we're going to have to pay attention for when we go to graph later. Now we did done one in class last week where this came out to be x squared and x squared. And that meant it was a quadratic asymptote. That's when it shot up in the air like a parabola. This one's going to form a line. All right, let's see what else we have. We have x equals -1. So we have a vertical asymptote right there. No holes. But we know we hit it -2, 0, 1, 0. Oops, wrong spot. That's 1, 0 right there. And 0, -2. So we hit here. All right. So now I hit here and here. So that means I'm going to, let's see. Oop, that's not -2. Right there is -2. Let me fix that. My little whiteout tape. I actually put it on the vertical asymptote. So right there is my vertical asymptote. This is the point 0, -2. So I'm coming up through here, and I'm going to hug this diagonal asymptote. And I know I have a vertical asymptote here, so I'm going to go down. Now on this side, I know I hit here. So I'm going to come up across my vertical asymptote. Don't cross over it, you're hugging it. And as I come down this way, I'm going to hug the diagonal asymptote. And that's my picture there. All right, let's do the bottom one. So I'm going to factor this guy. So let's see, this factors into x minus 2, x plus 1. Then I'm going to factor out an x here. And this factors into x plus 4, x minus 2. I'm going to cross that off so I don't look at it anymore. All right, now notice here, x minus 2 cancels off with x minus 2. That means there's going to be a hole. There's a hole at x equals 2 that we're going to have to pay attention for. So if we plug 2 into what's left over, that means we have 2. That'd be 3 over 2 times 6. So that's 3 over 12, which is 1/4. Means we're going to have a hole at 2 1/4. All right. X-intercepts. What makes now? I have what's left over, -1. So we're going to have a point at -1, 0. Plug a 0 into what left over. So we have a 1 over 0 times, oh, can't have that, so there's none. Vertical asymptotes, we have one at x equals 0, x equals -4. Horizontal asymptote, okay. Now when we're deciding the horizontal asymptote, we always go by the original equation. What's the most powerful thing in the numerator? X squared. What's the most powerful thing in the denominator? X cubed. Now, if the denominator is more powerful than the numerator, we're going to 0. So that means my horizontal is y equals 0. All right, so let's graph this thing. So I know I have a horizontal asymptote, y equals 0. Okay. I have a vertical asymptote, x equals 0. X equals -4. Okay, a hole at 2 1/4, which is right out there. So you put an open circle. We're going to hit the x-axis at -1, 0, so right there. Okay, and no y-intercept, and that's because there's a vertical asymptote at 0. All right, let's see what this picture looks like. I know this point. And I know this is my horizontal asymptote, so from here I'm going to hug this line, and from here I'm going to go up, like that. All right, now in here, I know this point, but I don't know which direction to go in, so I'm going to plug in -2 into the leftovers and see what I got. So that makes -1 all over -2 times 2. So that's -1 over -4, which is 1/4. So I know at -2 I'm at 1/4. So that means I'm going to come up off this dot and go up and come down. And then let's plug in -5 to see what that makes. If I plug in -5, I get -4 all over -5 times -1. So that's -4 over 5. So here I'm right about there. So I'm going to go hug the line here and hug the line down. And that's what our picture looks like.